Hello YouTube viewers, welcome to my show Future Friday. In today's episode, we're gonna take a closer look at moon base before Mars. So let's dive right into it. Now first, let's get a very basic scientific understanding of the situation. Now first thing you have to understand, moon is far. How far? Well, if you are traveling at light speed, it will take you more than a second. It's upwards of 3,84,400 kilometers. So it's far, and yes, it does fluctuate a little bit, but this is the average. So basically at light speed you can still expect more than 1 second. Now when it comes to Mars is ludicrously far. Now most people can't comprehend the distance because there are, even at light speed it will take you upwards of 20 minutes to get there. So it is very far, and also again distance fluctuates. So that creates a very big conundrum. Now many times people always say, especially those who want to support communism, is like why the heck America win the space race when Russia did everything first, like first rocket to orbit, first satellite to orbit, first animal to orbit, first man to orbit, first woman to orbit. If everything was first by Russia, then why the heck Soviet Union, then why the heck America is classified as the winner of space race? Now one thing you have to understand, every Russian achievement was below 500 kilometers. And let's say even if you give them the benefit of the doubt that orbit was not perfectly circular, the highest point they ever reached was 5,000 kilometers. This was 3 lakh, as in like 384,000. So like there is a lot of extra zeros here. So that is the reason why people say America won the space race. So when you talk about Mars, it's completely different ballgame. Like the amount of distance we have to traverse is ludicrously far. Then let's come to the scientific facts of these places. Earth, you know the fact that Earth has 9.8 meter per second square of gravity. That is what we classify as 1g. So that's what you are familiar with, that's what you are doing right now. But when we go to moon, you are talking about 1.62 meter per second square. Now it's a very big, relatively speaking it's very big, but that also does not mean it's zero. So as in like your rocket still needs to expend a lot of fuel to get off it. When come to Mars, we are talking about 3.711 meter per second square. Now that's upwards of 40%. So when you are talking about moon, you are talking about less than 20%. When you are talking about Mars, you are talking about less than 50% of gravity. When we are talking about atmosphere, Earth has upwards of, at sea level, 14 psi. Now that's good enough. That's what we classify as 1 atmosphere or 1 bar. So that's the whole idea of Earth's atmosphere. When you are talking about moon, zero, absolutely zero. Now of course it's not 0.001 is there, of course, but it's more or less zero. But when you are talking about Mars, you may also feel like it. Mars is also a partial vacuum, but it still, you can measure it as in like 0.087 psi. Basically it's less than 1 psi, but you can measure it. So it's not negligible, and it does play a very big headache. So this is the science aspect of it. Mars is really far. Then we talk about distance and rockets. Now this is the aspect that you have to understand, that rocket has to fight what we call Earth's gravity. So all rocket, let's say take an example of Falcon 9 Block 5, they will because SpaceX is a company and they want to sell you a product, they will tell you SpaceX basically Falcon 9 Block 5 has LEO capacity, as in low Earth orbit, upwards of 22.8 ton. Sounds a lot, it is a lot, but when you take the same rocket and launch it towards Mars, your payload capacity goes down drastically, and I'm talking upwards of 4 tons. That's it. You went from 22 tons to 4 tons. That's it. That's it. And when you are talking about okay, let's not use basically simple Falcon 9, let's use Falcon Heavy with Block 5 edition, you are still talking about 63 ton to low Earth orbit. Now practically speaking, you can never send that much because the payload fairing size is limited. On top of that, the structure is not wide enough, so you will have very hard time actually putting something big, and is structurally not sound enough for 60 ton of loading. But you can put something heavy, lightweight, as in upwards of 16 ton. Now if you put 16 ton, you can send that to Mars. That is the benefit of Falcon Heavy, but still it's 16 ton, which is still less than the LEO capacity of normal Falcon 9. So you have to understand, distance and payload capacity do not mix well together. The only way to bypass is that you go to low Earth orbit with the biggest rocket you can do. Let's say you used basically normal Falcon 9, because I told you heavy version does not have that much advantage on top. We used normal Falcon 9, you went to low Earth orbit, you refueled it with whatever you have to do. You just keep refueling it with using multiple Block 5, and then you can go to Mars taking upwards of 22 ton, which will be higher than Falcon Heavy. So that is one thing you can do. Now, to give you a context, now most of you are familiar with the fact that International Space Station is built in blocks. Each blocks are less than 30 tons. Upwards, I think the heaviest block is upwards of 22 ton. To give you a context of that, now if you might be like, okay, 22 ton is enough for International Space Station, why it would not be enough for Mars mission? Well, for Mars mission, I want to give you a context of this. Basically, Skylab, America's first space station. This was basically modified third stage of Saturn V. This was 70 ton, and I want you to Google it. Basically, Skylab's interior, how much space was in it. When you are talking about something attaching multiple small things, you have to understand the biggest volume you're gonna get, as in like continuous unobstructed volume you're gonna get, would be limited by the fact that you are limited to 20 tons or 22 tons. For if you want to put a lot of people and you want to give them breathing room, you need to send heavy payloads. You cannot bypass it. You need to send big, heavy, large payloads. So that is the aspect of rockets. Then we come to the aspect of that there is a very weird problem with Mars, is that it has partial atmosphere. If it had zero atmosphere, it would have been better for us, simply because when you are going to Mars, you are traveling at what we call planetary velocity. You are traveling minimum of 20-30 kilometer per second upwards of, so that's a very high speed. But problem is that at that speed, even a partial atmosphere, as in at that speed, even 0.087 psi becomes so dense that you need heat shield. Now, heat shields are big, heavy, expensive, bulky, and dangerous, because if heat shield cracks, your whole things will basically turn to ash. So we need to have heat shield. Now, this partial atmosphere, you might be like, okay, let's use heat shield, but also use parachute to slow down. Now, this is where Mars really becomes annoying. It's like it has you have to have heat shield. You might be like, might as well use parachute. Now, if you use parachute on case of Earth, you can slow down from a certain speed to zero, basically a safe descent speed. You cannot do it on Mars. Basically, if you open the parachute as big as you can make it physically, within physical constraint, you still will hit the surface at more than 300 km per hour, because that there is not enough atmosphere. So that is why parachute has been scrapped. The idea of parachute has been thoroughly abandoned. So what NASA right now has to do is basically case of, let's say, Curiosity rover. They had a rover, basically they had this, went into atmosphere, heat shield was ejected, small parachute was deployed. Now that parachute was what we classify as supersonic parachute. It was designed so it can work at supersonic speeds. Now it slowed down, but it, of course I told you, like it cannot hit zero. So then they fired a rocket engine to slow down to zero. So you can understand it's a really frustrating, and that is the core reason why SpaceX is directly ditching parachute and is like, just use rocket. If we have to use rocket at the other end, might as well make the rocket big and bypass the stage of parachutes. So they will have heat shield, rocket engines, done. So that is the problem with partial atmosphere. It's not zero for us, nor it's enough for us. Then comes the long travel time. This is the aspect that you have to understand. Radiation has a what we call cumulative advantage to it. Basically, the longer you tow, let's say a very little amount of radiation is there, okay, no problem. But if you are staying there for a very long amount of time, you're gonna be dead. So in this sort of scenario, when you are talking about space, let's say space has a radiation value of 1. Now, if you are living in that basically radiation environment 1 for 1 month, okay, your body can recover. If you are living there for 6 months, you dead. So that creates a problem when the quickest route that people generally take is what we call home and transfer method. At that time, Mars and basically Earth would be the closest. That still takes 2 years. Now, if you can like use infinite fuel, basically hacking, you can go upwards of 6 months. That is doable by some methods, but practically we can't do that reliably. But let's say you did that, you are still in radiation environment for 6 months. We have to cut down that travel time. Travel time is basically lethal for us at this point in time. So any astronaut going to Mars, if they come back, they will die very quickly because of normal cancers, or you have to spend a lot of money and resources just to make sure the cancer does not become a big issue. And I'm talking while they're going to Mars, not like while they have stayed there and come back. By that time, they will have cancer. It's not an option, they will have it. And on top of that, let's say you figured all that thing out, Mars is very far from Sun. So basically your solar panel is might as well useless. Now NASA learned this the hard way once they have already sent the rovers. You have to understand, when we see rovers from the camera that they have on them. So we give an idea like, okay, this is how big it is. In real world, rovers are very small. They are very small and very light. And on top of that, they are extra light by the fact that Mars does not have enough gravity. So whatever you measured, let's say it's 1.5 ton here, 1.5 ton on Earth, it won't translate to 1.5 ton on Mars. So even in those sort of scenario, even when you had that advantage, Curiosity rover, which was upwards of 1 ton, realized this very early on in design phase, that we simply cannot rely on solar. Because because what we call inverse square law. You can check my detailed video about here. Inverse square law simply means even though your distance is only twice as far, you don't lose half the power, you lose 90% of the power, you barely get 10%. So a solar panel that will give you 100 watt of power on Earth will barely give you 10 watt on Mars. On top of that, because Mars, again, this partial atmosphere, it still has enough atmosphere that it has dust storm. Now that dust storms can last upwards of a month. You cannot rely on solar energy here. So that is why Curiosity is relying on what we call thermonuclear electric generator. So this is the problem with Mars. Okay, then the question becomes, why Moon? Because at the end of the day, we want to go to Mars. Okay, now awesome Mars. Then what's the benefit of applying a stoppage in Moon? Well, Moon is very quick, as in you can go there in 3 days plus or minus. And it has infinite solar power, relatively speaking. It does not have absolute infinite, it's just relatively speaking, it has so much power. If we utilized even few percent of it, not 100% of it, just few percent, it has enough that it can allow us to expand an entire solar system and send entire Earth's energy bill without breaking a single sweat. So understand this, the amount of power available in Moon is way high. Why? Because it is basically environmentless. Basically there is no atmosphere, there is no cloud, there is no rain, there is no humidity. So that is very awesome. And on top of that, solar panels are not very practical in this sort of scale. When you are talking about megawatts and gigawatts of basically solar farm, solar cells are very expensive. And on top of that, you can't build solar cell practically on Moon. Solar cell is a very, very high-end silicon technology. And on top of that, silicon is not available readily anywhere. So, and on top of that, the solar cells that we use in space industry, they are what we call multi-junction solar cells. Multi-junction solar cells have things that I cannot even pronounce here, like it has zirconium, niobium, and these sort of advanced things are mixed into making the alloy good enough that it can make good cells. Benefit, 50% conversion efficiency. Side effect, cost more than an arm and a leg, and it cannot be done on Moon. However, we can do something, you can check my video about here, we can do what we call solar thermal. Now solar thermal does not work very well in Earth because of atmosphere, because you cannot create temperature gradient. On Moon, you can create hot side, which is very hot, upwards of as many high temperatures as you want, 3000 degrees or 5000 degrees Celsius, and cold side, negative, very close to absolute zero. So on Moon, using Stirling engine and solar thermal, you can get a lot of power using aluminum alone. That's it. You don't need any silicon technology. You just need simple hammer and metal and lathe, of course. So that's the whole point. That is why we have to use that, because A, we can make it on Moon, B, it will give us more power because it utilizes more of the electromagnetic spectrum to turn into heat, which actually gives us much higher efficiency. So we have a lot of power in basically Moon. On top of that, it has no atmosphere, which directly translates us to making, let's say you are making a lander for Moon. You see, this does not look very smooth or anything, like, it does not have heat shield and all that. You don't need that. Why? It does not have atmosphere. That means you can design very fancy things. Basically, in case of lunar lander, the lunar rover was placed into the lander stage, and there was a basically dropout camera. So when you see Buzz Aldrin like stepping down, or no, Neil Armstrong stepping down, the cameraman, there was no cameraman, it simply was, there was an arm with a camera on top that folded out. So that was camera somewhere here. So the benefit of that is, because you can make your structure in whatever way, shape, form you need, it saves money. It allows you to do something very small, something very interesting. This is very advantageous for us, and also for solar power, because you don't have to worry about dust storm that can block your sun for 1 month. So that is why we want to go to the Moon. Now, does it allow us to colonize Mars? Short answer, yes. Why? It acts as a great supply chain. Now, if you are familiar with anything that actually happens in real life, you have to understand there is a giant supply chain behind it. Let's take an example of, let's say, D-Day in World War II. People are familiar with the fact that soldier went there, fighting. Okay, awesome, everything is good there. But you have to understand, behind the scene, there were hundreds and thousands of troopmen, people whose sole job was just to make sure that there is an infinite supply, like quote unquote infinite. Basically, they had to make sure fuel for the boats, basically fuel for humans, aka food, fuel for gun, aka bullets, all of them have been continuously served. Factories were working 24 into 7. They had like buffer on top of a buffer, train after train, trucks after trucks. There was a giant supply chain that was made sure, and they had redundancy. So like, let's say something happened, one ship got destroyed, they had another ship for backup. On top of that, they had multiple stockpiles in different places, so anything bad happening that will not destroy the supply chain. We need these sort of thing if you want to send people on Mars for long term. If you want to send them, just go there, land and come back, yeah, you can do that today. But if you want to send them and make them like, okay, go stay there, that can only be done if we have moon, because moon acts as a great supply chain. Now, can you do this from Earth? Short answer, no. Why not? Earth has ludicrously high gravity and ludicrously dense atmosphere. Basically, your rocket, most of the energies of your rocket is spent in just fighting the gravity and fighting the atmosphere. In case of, let's say you take simple rocket, nothing fancy, you just took a second stage of basically Falcon 9, you can still send more tonnage to Mars using just one stage compared to Earth. So that is the reason. If you want to send something to Mars and you want to send it enough quantity, as in I'm talking container ship, as in hundreds and thousands of tons of it, you can only do it from moon. And moon, because it does not have an atmosphere, you can use maglev. Maglev simply being, you have to make a very long maglev track, and it has enough energy, solar energy. Using maglev and energy, you can fire payloads at like, let's say, to 8 to 10,000 kilometers per second. I'm saying per hour. Isn't that speed very high? For Earth, yes, because even though maglev can go that fast, atmosphere will gonna destroy you. That was the whole concept of hyperloop. But when you are talking about basically in moon, there is no gravity. On top of that, because there is low amount of what we call gravity, you also have to fight less. So your 1 ton does not act as 1 ton. So there is another amazing aspect of that. So using the energy, using the low vacuum, you can literally send basically container ship. You can just fire container ships of material to Mars, and this will allow you to like act as a supply chain provider. That is necessary. You cannot have a scenario where like somebody on Mars is like, yeah, we need, let's say, 10 tons of aluminum. Yeah, 10 tons of aluminum sending from moon is sending from moon would, let's say, cost $1 million. Sending it from Earth to Mars will cost you upwards of few $100 million. So you have to understand, we have to do that. Before we go to Mars for a long term, we have to have the supply chain. Moon is the only option we have. On top of that, moon also has water. Now you can understand that even though we in space industry we have very good water recycling. Let's say your International Space Station has 98% recycling efficiency. Let's say for worst case scenario, you will try to make it 100%, but in real world you always have lower than that. So let's go with 90% water recycling efficiency. But when you're talking about 100 people, as Elon Musk is talking about, you gonna need thousands of tons of water. And I'm talking long term, not just like, go there, land and just come back. If you're talking about staying there for years, you're gonna need really large amount of water, and you have to have fail safe. You cannot be like, okay, somebody accidentally damaged the airlock and water evaporated out. Yeah, that cannot happen. So you have to have an extra supply. Moon provides us that, because moon has enough ice that it can support basically small scale human colonization of Mars for long enough. As in, like, if you send from here, of course this is gonna dry out soon. But still, you have it for, let's say, 10 years, basically long enough to build a supply chain on Mars itself. So as of now, if you want to do the supply chain, you got water. On top of that, you can do matter supply. Basically, if you want to send oxygen to Mars, you have almost infinite amount of it on moon. So, and if you want to send silicon, of course, you have upwards of 20% of lunar surface is silicon, upwards of 12% is iron, and then there is upwards of 8% calcium and 7% aluminum, which is very interesting for space industry. Then you have magnesium, which will allow you to make interesting alloys with aluminum, and then also you have other things. So basically, it's more or less like Earth's crust. So you can really utilize moon as a supply depot. So we go to the moon, we set up a supply chain, then we go to Mars, then we can sustain Mars. So if something bad happens on Mars, let's say some habitat goes, some big parts get out destroyed because of meteoroid or something happens, we can instantly send repair parts or supply parts and water and everything from moon much more quickly than we can do it from Earth. So that is why, for sake of Mars, we have to have a supply chain. Supply chain is only feasible from moon. So we have to understand the moon will act as a very good foundation for us, and I'm gonna make multiple other videos about how to make the actual mission profile to do this sort of thing. So we have a lot of water. Now when I say lot of, don't think in terms of earth level, like have ocean scale water. It's just like a very large lake amount of water we have. Then we have abundance of building material, which is very necessary, because you cannot build materials from like leg earth and all that. Even though if you try, like you can make the structures out of it, but you have to have a skin of some material. Generally it will be plastic, or you can use aluminum. Would be very easily available here, so we're gonna use aluminum so we can get airtight. This is the crucial reason. In earth we can do whatever we want because we don't have to worry about making it airtight. In case of space, in case of moon, in case of Mars, we have to worry about those things. That is why we need advanced building material, aka aluminum or iron or whatever like that. Then oxygen. This is the funny part about moon has near infinite amount of oxygen. Now quote unquote infinite, it just has more than enough than we need. Then it has abundance of solar power, because at the end everything, matter is just one part of the equation. If you have matter plus energy, then you can do things. If you have only matter, it's pointless. If you have only energy, it's pointless. Matter plus energy gives you awesome things. So moon has both of them. Then it's very easy to reach there and easy to leave. So you don't have to worry about giant thermal shields to land on the moon. The gravity is weak enough, so even a small rocket can land. Even a small rocket can take off big chunks of payload to orbit, and we can directly use maglev for launching system. So that way we can truly build a supply chain where you can have, like, every month we can send 100 tons shipment to Mars. So that way you can actually be confident enough that, let's say you sent hundreds of people on Mars, let's say one BFR full of people, you will have enough of a supply chain, enough things going to the Mars, so you can be confident that they can easily build everything. They can easily have redundant power supply, easily have independent, like, multiple escape capsules, multiple, like, as many things as they can need, because the first 100 people, they have to make it in the terms of long duration. If they make it long duration, then human colony can be built from there. But if they don't have material, because they can't have material, even though, let's say, Mars itself has a lot of iron, you can't extract it. Why? Because you don't have enough energy unless you put giant nuclear reactor there. So for this reason, we have to lay the foundation of our existence, of our space colony, basically on moon itself. Only side effect, only thing missing on moon is basically it does not have hydrogen. So the only place where we can easily get hydrogen is basically Europa. So that's again another moon. So that is the aspect of it. You have to understand it. Like, if you want to go to Mars today, like go there to land and come back, we can do it very easily, no issue there. But if you want to send there and, like, create a basically environment for people to live there for long term, as in, like, not coming back, you have to have a big supply chain for until they can establish their own supply chain. And even in long term, you still need a supply chain of fancy things. So this is why we have to lay down the foundation of our space colony on moon first. So this was my presentation on why we have to go to the moon first, like, for long-term mission before we go to Mars. So this was my presentation. I hope you liked it, learned from it. In that case, please click the like button and click the ad that are shown in this video. That will directly help me. And if you didn't like it, don't worry about it, you can press dislike. I would urge you to press this twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.